We are focused.
Oh, my God,
Focused.
we video.
All right, and Lucille has her hand up, so what are we doing, Lucy?
Number 4 on 3.2.
3.2, homework, number 4. Okay, they give me an equation. One, two, three, 1, 2, 1, 16, hopefully I got it right. And it says, the amount present in a certain substance, okay, after 2 years is given by this. Estimate the half-life of carbon-14. So what does half-life mean? The amount of time it takes to end up with half of what you started with. So I don't know how much I start with, it really doesn't matter. I'm gonna end, oh, well, actually, I do know how much I start with. I start with 20, so I'm gonna have to end up with 10, right? Those two numbers are irrelevant though. It could be 6 and 3 or 12 and 6, it could be lots of different things. But this is our setup. So we'll divide, you get 1/2 equals e to all this. And then how do we solve that? We probably take the natural logarithm of both sides. So ln 0.5 equals negative 0.00016t. So we'll just divide ln 0.5 by that number. And I got 5,700.22, is it years? Yep, years. Okay, Lucy? All right, Oliver?
3.6, number 7.
3.6, number 7. Yes, this is our credit card. Okay. He plans to pay the card off in 2 years. How much are his monthly payments? Okay, monthly payments means I'm gonna use one of the formulas on the little purple sheet I give you tomorrow, FP and PV. This sheet has PV, FV, and Newton's law of cooling on it. Those are the things you're not responsible for. Everything else you are, okay? So, which one am I using, PV or FV, if I am paying off my credit card?
PV.
PV. So here's the PV formula. Alright, so let's see. What is the present value of my bill? 2345. Yep. I am looking for my payment amount. The interest rate is 0.2199. And I'm doing it monthly.
How do we know it's monthly?
How much are his monthly payments?
Oh.
So the interest has to be computed every month. What's N? Well, N is how many payments I'm going to make altogether. Since I'm doing it in 2 years, monthly, that's gonna be 24. And this one is negative in this formula. And then 0.2199 over 12. Okay, so as often happens with this kind of problem, we're gonna figure out what this is and then divide 2345 by that. So here we go.
Just put 1 in for everything. So I did 1 year, 12 months. 12. So she said 12 months, 1 year. So just choose it. So basically, you basically, yeah, you just have to pick the number of years. That's all you have to do. I just did it, but it's kind of order.
I got payments of $121.64.
do you too?
Yes, I'm not done with the problem, Lucy. Just be patient. Why is your coat on? Why is your coat on? Why are our coats on? We don't wear our coats in school, in the classroom. If you are cold, I totally get it. But wear a school sweatshirt. Or if you're a senior, a college sweatshirt. All right, so this is how much the monthly payment is. All right? So, this is how much he's gonna pay 24 times. Agreed? So I'm gonna take 121.64 times 24, and that means that to get this thing paid off, I'm paying 2919.36. Well, how much extra am I paying then? Because instead of buying the stuff outright, I charged it on my credit card and did it in payments. I only bought this much stuff. So subtract 2, 3, 4, 5, and I'm paying an extra $574.86. Now I know what some of you are thinking. Some of you are thinking, that's not that much money. Well, we only borrowed $2,000. So if we take that and divide it by 2, 3, 4, 5, it's like 25% more extra. You paid 25% extra because you didn't pay this off right away. Credit cards are money suckers. They take away your money. Please don't tell your parents, Mrs. Ford said don't use credit cards. I use my credit card all the time. So pay it off. These rates are crazy. Don't buy what you can't afford. That's the bottom line. Don't buy what you can't afford.
Sorry, I got a little lost there. How did you get $574?
It's this much times 24 is this much. That's how much I pay altogether over 2 years.
And then
That
subtract
is that much more than what I borrowed.
Okay.
So I paid for the privilege of using my credit card, I paid 25% more.
Okay. So is your answer times,
This is
how
the
many times
answer
did
to
you-
one question.
Uh-huh.
This is the answer to the other question.
Okay.
Sarah?
Can you do 3E on the chapter 3 review, no calculator?
Chapter 3 review, no calculator. 3, which one?
E.
E. Now, no calculator means you're probably not going to be using logarithms, right? So when I would look at this problem, just first glance, I see my variable as an exponent, and I'm immediately thinking, oh, I'll just log both sides. Well, not if I don't have a calculator. So if I don't have a calculator, then somehow I have to get a common base out of all this. Well, luckily, 16, 2, and 32 are all powers of 2. So 2 to the 4th times 2 to the x plus 4 equals, okay, 32 to the 1/2 would be 2 to the 5th to the 1/2. Does that make sense to you? The radical is the 1/2. 32 is 2 to the 5th. These two guys are being multiplied. So what am I going to do with their exponents? Add. So I have 2 to the x plus 8 equals 2 to the 5/2. Well, if 2 to the x plus 8 equals 2 to the 5/2, then x plus 8 equals 5/2. And x equals whatever, what is that? Negative 11/2, negative 5/2, negative 11, or negative 5.5, negative 1/2. Okay? Gotta be able to get a common base. Only way to do it without logarithms.
For number 1B, also in that section, I just have a question, like conceptually. So when we have that,
I'm listening.
okay, when we have that 3 right there, as our base, do we disregard it when we're graphing?
Well, yes, for purposes of end behavior, because every exponential is gonna look like that. And it doesn't matter what the base is, it's gonna go through the point 0, 1 and have an asymptote asymptote of y equals 0, as long as there's nothing else thrown into the problem, okay? Now, this takes care of the 3 to the x part, okay? Now, if it were 2 to the x, it would have exactly that same shape. If I graphed them side by side on the calculator, one of them is gonna be steeper than the other one, you know, one's gonna look like this, but that's a curvature thing, it isn't a shape thing. The shape is gonna be that for every single one. 2, 3, 4, 5, it doesn't matter. So when you start putting extra numbers though in, things can change. So what does the x plus 1, what does adding 1 to the exponent do? No, the x plus 1.
Oh,
The x plus 1 takes it left. So instead of it having a point, instead of it going through the point 0, 1, it's gonna go through the point negative 1, 1. You with me? But it didn't change the asymptote, it just moved it over a little bit. Alright? Now, what does the plus 1 on the end do? Okay, that changes some stuff. Because as soon as you take it up 1, then this point, first of all, will be at negative 1, 2 now, right? And that asymptote, instead of being at 0, it is now at 1. Curve is exactly the same, we haven't changed that. So now the purple is a picture of what I've got. So the end behavior has to be, I gotta look at the purple. So as I approach, as I go right on the picture, that's just positive infinity, isn't it? But be careful, as you go left, what's happening as you come left? We're getting closer to this asymptote, which is 1 from the top.
and then,
So, back to your original question. Had the 3 in the problem, then a 2, none of that would change.
it would only change if like it was like in 1a where it's a half, because that would be exponential
Yes,
decay.
yes, because
Okay.
that changes the exponent, because 1/2 is 2 to the negative first here. Yeah.
Can you do 6B?
On this same paper,
Yeah, on the
6B says use the asymptote, domain, range, and y-intercept. Alright, well, first of all, you have to know what a logarithm looks like. I mean, not that one in particular, just in general, what does ln x look like? Well, it has an asymptote here, an intercept here, and it looks like that, right? That's your logarithm. Obviously, we've stuck some numbers in there and we've changed things around a little bit. Remember, you can't take the logarithm of 0, right? This is ln x. And wherever the 0 would be, that's where your vertical asymptote is. So where would the 0 be here? What would make this 0? 3. So your vertical asymptote is going to be at 3. Wherever the 0 is the asymptote. Alright? Now, what does changing the sign on X do to your picture? It flips it this way, but your y-axis is now here. What was the y-axis is now here. So your picture is going to look like this. So, where's the asymptote? The asymptote is x equals 3. What is the domain? What are your x values here in this picture? Negative infinity to 3. That's your domain. What is your range? All reals. That's your range. We'll say negative infinity to infinity. And your x-intercept. Now, you can tell from my picture where the x-intercept is, But how can you do that, maybe without having my picture there? Well, remember, in a normal picture, the x-intercept, in a regular logarithm, the x-intercept is at 1. Why is it at 1? Because the log of 1 is 0. Right? So in order to find the 0, the x-intercept, I need this to be 1. Because the only way to get 0 out of a logarithm is to take the log of 1. So to make this be 1, x would have to be 2. Now, it also works if you think about reflecting across this line, you become 1 unit this way. And so that, you can use that logic also.
And will that point always be 1 unit away from the asymptote?
Yep. Unless you have done stretching and shrinking and all that.
We always reflect before we translate. All that, or does it make a difference on the order?
What do you mean?
Like we had a reflection over the y-axis and we translated it 3 units.
Okay, you gotta be really careful because if you, okay, so if we turn this around, it's negative x plus 3, which is negative x minus 3. So it actually goes 3 units to the right, exactly how we said it would, and it reflects across the vertical, wherever the vertical is. Now, what I like to do, Oliver, I think that complicates it. I like to remember that my asymptote is wherever the 0 is. Wherever 0 is the asymptote, that's gonna be a 3. That's not gonna change. No reflection, nothing's gonna change that. And so then you can kind of figure out after that.
A negative sign from the natural law of this, will that reflect it across the asymptote? Or
Yes, yes, yes. Across the
like
0.
an X across the 0?
Yeah.
Okay.
The new 0. Tess.
So if it's negative ln, it would go from like a regular shape and it flipped.
Negative ln would look like this because it flips this way. I mean, across the x-axis.
Do you do 4A on the review on the calculator part?
Calculator part, 4A. I think I already did this, didn't I?
Yeah.
What is with you guys in the back row back there? All right, look at yesterday's notes for that one. Yeah,
Did we
Sydney?
do, 3.6, the one we just got back, could you do 4 on the front?
So problem 3.6, problem number 4. Homework 3.6, problem number 4.
Actually, I think I changed my mind, I realized what I did wrong, can we do 2 on that one?
Do whatever you want.
Thank you.
All right, 2. IRA Andrew contributes $50 per month. That's gonna be a payment, right? That's gonna be one of my purple sheet ones. What is the value of investment after 20 years? PV or FV? FV, so we'll write that down.
What are you looking at?
All right, there it is, there's FV. All right. 50 is his payment amount, so that goes right here. Wow, 15.5%, that's pretty awesome. So that would be 0.155 divided by 12 monthly. And we're doing this for how many years? 20 years times 12, 240? All those numbers make sense to you, Sydney?
Yes.
All right,
I see what I did wrong, yeah, looking at it, I just set it up.
so I'm gonna go ahead and type it in just to do it. Can't leave it unfinished. get $80,367.73?
Yes.
All right, who else?
Can we do 3C on the no calculator?
No calculator. 3C.
So you plug that in and you want to do the same amount of money at the same amount of time, but just change.
Okay, it's a logarithmic equation.
Out of 1 hour. Not go 1.
You cannot solve a logarithmic equation if you have more than one log on either side. So you got a couple of options. Since that's a zero, we could actually add that to the other side. This would be an option. There's another way to do it, but because that's a zero, I would never in a million years do it if it were any number other than zero. But since it's a zero, I can go ahead and add it over, right? Now I have one logarithm on each side, which is like perfect, except this one has a number out in front of it. So I'm gonna multiply both sides by 2. Oh, that's not gonna help, because that's just gonna move it over here. What am I gonna do with that 1/2?
7x plus
Bring in an exponent. So ln 2x equals ln 7x plus 15 to the 1/2. As soon as you get ln equals ln, or log equals log, you can drop them out. And now we have an equation to solve. Right? So that means a radical, doesn't it? So how about we square both sides? Let's try it. 4x squared equals 7x plus 15. Is that okay? So we're going to set equal to 0, 4x squared minus 7x minus 15. I wonder if that factors. It does? He says it factors. If I don't want to factor it, I could use the quadratic formula. I need a 5. 5 and 3. Yeah. Is that okay? Yeah. So my x's are -5/4 or 3. Be really careful. Always in logarithmic equations, you need to check for extraneous roots. But for double sure, we do in this one, because when you square both sides, you introduce extraneous roots. So we want to go back to the original equation. Can x be a negative number? No. So that's wrong. I'm going to put in 3 and make sure that works out, because it could be extraneous because of this. When I square both sides, I get bad answers sometimes. So that would be ln 6 minus 1/2 ln, what am I putting in, 3? What's 21 plus 15? 36? I think that checks, doesn't it? ln 6 minus ln 6. So the only answer to the problem is 3. John?
On the very front side of the review packet, can you do
9C?
Yeah.
Well, 9C is problematic because I have some numbers that don't match that I would love to have match. So, remember, there's a property of logarithm that says if these two match, then the answer is just that, right? So if this were 3 log base 3 of 10, the answer would be 10. That's a property. When they don't match, you can't use that property. So what I would suggest doing is just figure out what this equals. what's the log base 4 of 64?
3.
Well, let's see, the log base 4 of 64. Isn't 64 4 cubed?
Yeah.
So the log base 4 of 4 cubed is 3. So this equals 3. That is 3. So the answer to the problem is 2 to the third, which is 8. Tess?
Can you do 4B on calculator?
Calculator review for B. I don't think we've done that one. Alright, the population of Precal is 2718 in 1995. So my starting population is 2718. It is increasing at a rate of 2.3%. So that is 1.023. That's what I would multiply by. Right? So after 1 year, whatever that is, that would be the population after 1 year. And then for the next year, I would just take that and multiply it by this again. Because every year it's going up 2.3%. So I want to know when it's, what is the population, there's just 2 questions. What was the population in 2010? Well, let's see, I'm just gonna raise this to the 15th power, aren't I? Because it's 15 years from 95 to 2010. So that will be the answer to the first question. Then when will the population reach 30,000? I'm gonna have to solve that to find out how many years it's gonna take to get to that. So we'll start by dividing. And then logarithming. And dividing again. So I think, Tess, the answer is I got 105.6. So it's gonna take a long time. So when did we first start measuring? 1995. So it's gonna be sometime in the year 2100 that we reach that population.
Can you do calculator review for D?
For which one?
D?
D?
Yeah.
D? Population of deer is modeled by this equation. This is a little logistic equation. Alright, what was the initial population? When will the population reach 1800? Well, we can do what is the maximum population? Right there, right? That's your limit to growth. So that's the maximum population. What was the initial population? Well, how do we find the beginning value? We let x be 0, right? We let x be 0. The beginning value is when time is 0, right? That's the starting point. So what happens if you put 0 in here? What happens here? If you put 0 in for t, it gets rid of all that, and you have 2750 divided by 11,
250.
which is 250. So the initial population of deer was 250. Everybody okay with that? When will it reach 1800? Well, using the same equation, but now we're putting the 1800 over here. we solved that. Multiply it over, so to the 1800 plus 18,000 e to the negative 0.04 t equals 2750. Subtract the 1800. Where is that, 950? Oh, keep an eye on my arithmetic, please. Then we'll divide by the 18,000 number. What is that? Probably spam.
Yeah.
Alright, so we take the natural log of both sides. So aren't I kind of out of room down here, aren't I gonna take ln this fraction divided by negative 0.04? And that should be my answer. The 18,000. I got 73.54. What was the deal there? In 73.54 years. Okay, didn't we?
Do 3A on the calculator.
On the calculator part, 3A. So I'm just gonna go to stack. And I'm gonna put those numbers in, so 2, 6, 8, 10 are my X's, or my L1s. And 1.3, 6.7, 8.5, and 12.6 are my L2s, or my Y's. Now I'll go over to calc, I'll go down to exponential regression, right? Yep, exponential regression. And see what happens.
It's like.
Where you can go down to exponential regression.
So, the calculator tells you that that's the format of your equation, but you knew that already. That's what an exponential looks like. So mine says 0.8714 times 1.3287 to the x. All right, that's the first part of the question. Then estimate the y value associated with x equals 4. So all I would do now is type that in with that being 4, and that will give me my y value.
If you were to type that in, isn't there an option where you can hit like when you do like the trace? Isn't there a value button you can put x equals 4?
Yep.
Okay.
Yep. If you grab it.
Oh my gosh.
What was the answer for 3.21b?
Homework
Homework.
3.2 1b. I got decay 0.32%.
0.32%. Okay.
Leah?
On the note calculator review for number 38, when you distribute that through
Calculator.
letter H,
Mm-hmm.
when you're trying to get rid of that 3 in front, because it is our exponent, can it go to both the 2 and the plus 2?
Oh,
or
no. It only goes, yeah, because it's on that logarithm. It's not on the.
So that plus 2 is just, unless it has parentheses around it, it's just out of the problem.
It's on the logarithm.
Could we just solve that one?
Yep. Alright, so now we're doing on the review sheet, no calculator. We're doing problem, what was it?
H.
Okay, 3H. So I think Amina was on to something when she said, I want to get rid of that right there. So I'm gonna make that ln 8 plus 2. Would you agree with that? Now, as always, there's different ways to go, but you're not dropping any logarithms at this point. You understand that, right? This does not have a logarithm. So you could give it a logarithm by remembering that the number 2 is the same as ln e squared, right? So if you wanted to do that, you could say plus ln e squared. Then you can put these two together now and say ln 8e squared. Because a plus, they go together as a multiplication, right? Your properties of logarithms. So ln 4x minus 2 equals ln 8e squared. Now you can drop them. So 4x minus 2 equals 8e squared. You're solving for x. So 4x equals 8e squared plus 2. So x equals 8e squared plus 2 over 4, or 4e squared plus 1 over 2 if you reduce it. So that's one option. So one option is to rewrite the 2. You can rewrite any number that way. Log base 10 of 10 squared, 2. Okay, that's one option. The other option would be to subtract this guy over to this side, back up here, well, here. So subtract that over, so you'd have ln 4x minus 2 minus ln 8 equals 2. In other words, put the logarithms on the same side. Now we can put them together, so the ln 4x minus 2 over 8 equals 2. ln 2x minus 1 over 4 equals 2. Now, what's the base right here? E to the second equals 2x minus 1 over 4. And when you solve for x, guess what's going to happen? You're going to get this, right? So you can do it either way. But you have to deal with that 2, one way or the other. So you can rewrite it, or you can move this over and that 2 then becomes an exponent. Got it? Sydney? Or whoever asked me this question, I don't remember. Was it you? Okay, sorry. Here you go. All right. Finley?
Do 5A on the no calculator.
5A, no calculator. Oh, come on.
I don't know what that means.
Come
Log 19 over log
on.
9.
What's our change of base formula, guys?
Big number divided by
Exactly. You need, come on. You can't be missing this kind of stuff. This is the log of 19 over the log of 3. And I can do it whatever base I want. So it says common logs, that would be base 10. It could be base 18 logs. It doesn't matter. It's the log of this one over the log of this one. Any base you want. Okay? Zoe's your hand up. Calculator 2A, I have no idea.
No.
2A, have I not? Okay, I don't remember. I did one of those.
You did
Do
B.
the other one.
I did B. So here we go. E to the x minus e to the negative x over 2 equals 7.5. All right, so what's our first step?
Multiply by 2.
We want to get rid of that fraction. So e to the x minus e to the negative x equals 15. Change it back into a fraction now. And then get rid of that one. So e to the x squared minus 1 equals equals 15 e to the x. Right? And then we can set it equal to 0. And let u or m or j or something equal e to the x if we need to. Some of you don't need to because you practice this enough. But if you do that, then you have u squared minus 15u minus 1, which doesn't factor obviously, but you can use the quadratic formula. So it's 15 plus or minus the square root of 225 minus 4 times a times c all over 2. So that's 15 plus or minus the square root of 229 over 2. So it's two different answers. But remember, these are u values. These are u's. So 15 plus the square root of 229 divided by 2. I got 15.0664. 15 minus the square root of 229 and negative 0.0664. Now, those are not the answer to the question though, guys, because remember u wasn't our original variable. We are solving for x. So e to the x is 15.0664, or e to the x is not negative 0.0664 because we can't raise e to a power and be negative. So that one's not going to work. I'll ln both sides. So x is going to be the natural log of 15. I got 2.71. I don't know how we're rounding off, but that's what I got. Okay, Zoe, got it? All right, Maren?
This isn't like one of the numbers, but just like annual percent yield. Is
That
there?
was a question, because somebody asked me and then changed their mind.
I
That's
just
on
did.
3-6 homework.
Yeah, at the bottom, I think 4 maybe.
Okay, so this is 3-6 homework number 4.
Just like a, I feel like I'm not in the right
So, well, if you just be still and listen. So, we have $3,000 that we are investing at 6% compounded quarterly for 1 year. Okay? That's what the problem says. So I'm gonna figure out what that is. That's easy enough to do. Figure that out.
I take that.
So I came up with 3184.09. So that is how much money I would have had at the end of the year. Everybody agree? From this account. Right? Now, annual percentage yield is, if we had only compounded once a year, instead of 4, because we have compound interest, what would have been that interest rate? So in other words, 3184.09 equals 3,000, 1 plus R over 1 to 1. What is that R right there? That's going to be your annual yield. So, don't let that confuse you. So we're going to divide this number by 3,000. subtract 1 from it, and that is about, I did not have any round off, I didn't use this number, I used the original number, but I got R to be 6.136. That's my annual percentage yield. Now remember, the bank, when I signed my contract or whatever I did, the bank said you're getting 6% compounded quarterly, but the effective yield of that was 6.1% because of the compounding. So that's all you're doing.
Thank you.
Okay. Who else?
Does that have to be a percentage though, or should we leave it like that?
What?
Does that, do you put that as a percentage? or is it
I did. That was a percent. I just didn't know what.
What are we locking in?
One more. Josh?
On the very front page, number 8,
Very front page of what?
overview.
Okay. Very front page of the review.
Oh, wait,
Number 8. Okay, which one? A, B, or C? A. All right. So, given that the log of 25 is 1.3979, find the log of 2.5. Well, isn't 2.5 the same as 25 divided by 10? And when I have the logarithm of a division, it's going to be the log of 25 minus the log of 10. That number they gave me. And what's the log base 10 of 10? So the answer would be 3979. C says the log of 0.04. 0.04 is 4 over 100, which reduces to 1 over 25, which is 25 to the negative first. Negative 1 log 25, so that answer would be negative 1.3979. We gotta know our exponents. All right, that's it. I wanna hand a couple things out in our remaining couple minutes. So you are gonna get 2 things. We're gonna get something from Sam and something from me. These are our notes and homework for our next unit.
So I dropped my calculator.
Chapter 4, just FYI, starts trigonometry, but trigonometry goes on and on and on. So we're gonna be with trigonometry for a long time. Please make sure you get 2 things. Not back up until you get 2 different things. Everybody has 2 different things.
I have a deep hate for geometry. Yeah. It's gonna go on and on.